Find the equation of the tangent from the point P with the coordinate 3, 4 to the circle x squared, y squared minus 2x minus 2y plus 1 equals 0. Here, we are going to use one method. So there are at least two methods, but I'm going to do the very simple method in this class. Maybe in another class, I will do a different method. Now, here we need to get this formula, this equation of the circle in the form, this form, well, h squared y is equal to radius squared. Okay, so we need to write it in this form. Now, remember that this equation that we have can be written, so the general form of this equation is this one, x squared plus y squared plus 2gx plus 2fy plus c equal 0. Okay. This equation has this form here. Now, what that means? That means 2g is minus 2. Because 2g is the coefficient of x, and the coefficient of x there is minus 2. So, minus 2. That means g is equal to minus 1. G is equal to minus 1. Minus g will be equal to 1. Now, 2f. 2f is the coefficient of y. The coefficient of y there is minus 2. So, minus 2. That means f is equal to minus 1. If f is equal to minus 1, then minus f is equal to 1. We see that the coordinate of the center of our circle will be, so minus g minus f according to the formula in your logbook, and this is 1, 1. So this is comma. So 1, 1 are the coordinates. So we have the coordinate of the center, and we are going to do here the same reasoning as in our previous question. What that means? That means if we have a circle here, okay, we have the circle and the center there. The tangent, if we have the point, I put the point, for example, there. So this, the center has the coordinate 1, 1. To write the equation of the tangent, I need to know the slope of my line. The slope of the tangent line. Because the tangent is a line, I need to have a slope. And I need to have a point. The point is there, the coordinate of point. We have the point. The point, we have the 3, 1. 3, 1. No, 3, 4, sorry. 3, 4. Now, if we draw an imaginary line, then the slope of this imaginary line, we need to get it. And then we will flip it to get the slope of the perpendicular line. Now, to do that, what we do, we write this formula that gives the slope: y2 take away y1, x2 take away x1. Okay, so y2 is there. Okay, y2 is there. 4 take away 1. So 4 take away 1. And then 3 take away 1. 3 take away 1. So I get there 3 over 2. So the slope of this imaginary line is 3 over 2. That means, okay, if this slope of the imaginary line, the slope of this imaginary line, let me call it M1, and it is equal to 3 over 2. Now, the slope of the tangent, that is a perpendicular, the slope of the tangent that is perpendicular to my imaginary line will be label it M2, and I flip it to there. I'm going to flip this upside down, and I'm going to change the sign. So this will be minus 2 over 3. So the slope of our tangent will be minus 2 over 3. Minus 2 over 3. Now that we have the slope, we have the point, we can write the equation of the line y minus y1 equal mx x1. So this is the formula. It is in our formula book. Now, I write now y minus what? Y minus 4 equals minus 2 over 3 bracket x minus 3. Then I'm going to multiply. I multiply 3 by this part, y and minus 4, and then minus 2 will be multiplied by what is at the right hand side. If I do so, I get here, I get 3y. This by this, I get minus 12. Minus 2 multiplied by x, I get minus 2x. Minus 2 multiplied by minus 3, I get plus 6. Then I'm going to bring everything to go to the left. If I do so, I'm going to get 2x plus 3y. And then I'm going to bring 6 as well. Minus 12 minus 6 will be minus 18, and then is equal to 0. So this is the equation of the tangent from the point 3, 4 to the circle that we have. Okay? Thank you.